Here we discuss the human voice and hearing. A complete description requires anatomy and physiology as well as physics. We'll stick to the physics, but recommend some other sources. First, to the voice. In normal breathing, we separate the vocal folds. When we exhale, air in the lungs at a pressure above atmospheric flows outwards. In speech, the vocal system converts a small proportion of the energy in this high-pressure air into sound waves. Let's start with a whisper. When air flows rapidly through a narrow constriction, it produces turbulence, which gives a sound spectrum with all frequencies present. To whisper, we bring the vocal folds close together and force air between them. Whisper. Other small apertures can produce turbulence too. The sound s uses a small gap between the tongue and the roof of the mouth. F uses lips and teeth. S, f. Whispering and sounds like s and f are called unvoiced speech because the vocal folds don't vibrate. In voiced speech, we make the vocal folds vibrate. Here's how. We pull them closed with a constant muscular effort. If the muscle tension is not too high, the air pressure below can force them open and release that pressure. Tension in the folds then tends to pull them closed again. Further, the high-speed air has lower pressure, and this also tends to close the folds. The cycle repeats, letting through puffs of air 100 or more times per second. Of course, you're not flexing your muscles that quickly. The muscular tension is nearly constant. The oscillation is periodic. Its spectrum, contains the fundamental frequency, the frequency of vibration of the folds, There are many harmonics and their amplitudes vary. Ooh. We'll see the importance of the harmonics later.